Imagine compressing the universe's 13.8 billion years into a single calendar year. In this mind-bending scale, every month, every day, and every hour represents millions of years of cosmic history. The Big Bang erupts at midnight on January 1st, and galaxies swirl into existence as the months tick by. For most of this cosmic year, the universe is a vast, empty stage waiting for something extraordinary to happen. On this scale, Earth forms in September, a late arrival to the cosmic party. For months, life is just simple microbes drifting in ancient seas, quietly shaping the planet's chemistry. These tiny pioneers are the only inhabitants, living in a world without plants, animals, or even oxygen-rich air. Then, in mid-December, everything changes. Life gets big, complex, and strange. Suddenly the oceans burst with new forms, and the pace of evolution accelerates like never before. This is the Cambrian Explosion, a burst of evolutionary innovation that shaped the animal kingdom. It's as if nature hit the fast-forward button, unleashing a creative frenzy. Suddenly, blueprints for almost all major animal groups appear. Creatures with hard shells, jointed legs, and complex eyes emerge, leaving their mark in the fossil record. Before this, life was small and soft-bodied. Think algae and bacteria. These early organisms left only faint traces, their bodies rarely preserved. But now creatures develop skeletons, shells, legs, eyes, and jaws. For the first time, animals could move, sense, and hunt in entirely new ways. The world transforms from a quiet microbial realm to a bustling ecosystem of hunters and prey. The seas become arenas of survival, filled with drama and competition. To understand this transformation, we must travel back over 500 million years, to a time when the continents were scattered and the atmosphere was alien. The continents and atmosphere were unrecognizable, but in shallow seas, a revolution was underway. These environments became the cradle of animal life, nurturing the first complex ecosystems. This wasn't just the birth of new species, it was the birth of animal diversity. The Cambrian seas teemed with creatures unlike anything seen before or since. Every animal alive today, including us, traces its roots to this event. Our own evolutionary story began in these ancient waters among these strange pioneers. The Cambrian Explosion is the ultimate origin story, asking, what conditions allow life to flourish and diversify? It's a question that echoes through time, reminding us how fragile and precious our world is. Fossils from this period are clues, snapshots of evolution's greatest experiments. Each fossil is a message from the past, revealing how life overcame obstacles and seized new opportunities. By studying them, we uncover how our world became vibrant and animal-filled. We learn not just about the past, but about the resilience and adaptability of life itself. It's a journey into the heart of what it means to be an animal. A story of survival, innovation, and endless possibility. And it all began in a blink on the cosmic calendar, a fleeting moment that changed the course of life on Earth forever. So, what was the Cambrian Explosion? It's one of the most remarkable and mysterious events in the history of life on Earth, a period that forever changed the course of evolution. It began about 541 million years ago and lasted roughly 20 million years. A blink in Earth's history, but a time of extraordinary transformation. For billions of years before, life was simple, mostly single-celled organisms and basic multicellular colonies. The oceans teemed with microscopic life, but complex creatures were nowhere to be found. The Cambrian marks the sudden appearance of complex animals with distinct body parts, mouths, eyes, limbs, and shells. This was a dramatic leap in biological innovation. These body plans, called phyla, are the blueprints for all major animal groups. The basic designs for everything from insects to fish were established during this time. Arthropods with jointed legs and exoskeletons and chordates with backbones both made their debut in the Cambrian seas. Both trace their origins here, in this ancient underwater world teeming with evolutionary experimentation. Nearly all modern animal phyla emerged in this short window. The diversity we see in today's animal kingdom can be traced back to this evolutionary burst. Before the Cambrian, the fossil record is sparse, mostly enigmatic soft-bodied creatures that left only faint traces in ancient rocks. Many pre-Cambrian forms vanished, evolutionary dead ends that left little mark on the future of life. Then the Cambrian rocks explode with fossils, shells, spines, limbs, and the first evidence of predation. Suddenly life became more complex and competitive. The world became more dangerous and more dynamic. Predators and prey drove each other to evolve new defenses and strategies. It's as if a blank movie screen suddenly fills with a cast of characters, each more bizarre and fascinating than the last. For Darwin, this was a puzzle. Complex animals seemed to appear out of nowhere, challenging his ideas about gradual evolution. Today, we know the story is more nuanced, with new discoveries filling in the gaps. But the Cambrian explosion remains a defining moment in life's history, a period of rapid innovation and diversification. Its evolution in overdrive, setting the stage for everything that followed, every animal, every ecosystem, every adaptation. The animal kingdom as we know it began here, in the Cambrian seas, a true explosion of life that echoes through every living creature today. To truly appreciate the Cambrian explosion, let's take a moment to glimpse the world just before it, a world both alien and strangely familiar. During the Ediacaran period, Earth's continents were clustered in unfamiliar shapes. The air was thin with much less oxygen, and the oceans were chemically alien, filled with minerals and gases that would be toxic to most modern life. Life here was dominated by vast carpets of microbial mats and the first large multicellular organisms, the mysterious Ediacaran biota, which flourished in the shallow seas. These soft-bodied creatures like Dickinsonia and Charnia had no heads, legs, or guts. Their bodies were simple, often leaf or disc-shaped, and they left only faint impressions in the ancient mud. They absorbed nutrients passively from the water around them, drifting or lying still, and lived in a world without predators, competition, or fear. Evolutionary pressures were minimal. There was no need for armor, speed, or complex senses. Life was slow, peaceful, and largely unchanged for millions of years. This peaceful, static world set the stage for dramatic change, as if the planet itself was holding its breath, waiting for something to happen. As the Ediacaran ended, something began to disrupt the calm. Subtle shifts in the environment hinted at a coming transformation. Perhaps simple animals started burrowing into the seafloor, breaking up the thick microbial mats and releasing trapped nutrients into the water, changing the chemistry of their world. This created entirely new food sources and ecological niches, opening doors for new forms of life to evolve and thrive. That simple act, burrowing, may have sparked the Cambrian explosion, turning a tranquil, static world into one teeming with innovation and diversity. The fuse was lit for life's greatest transformation, and the stage was set for an explosion of complexity that would forever change the story of Earth. When the Cambrian began, the seas filled with bizarre new animals. Trilobites, the era's icons, were armored arthropods with complex eyes and countless species. But they weren't alone. Evolution was in full experimental mode. Wiwaxia, a slug-like creature with spines, and Hallucigenia, with stilt-like legs and feeding tentacles, show just how weird things got. At the top of the food chain was Anomalocaris, a meter-long predator with grasping appendages and a circular toothy mouth. The rise of predators drove prey to evolve shells, spines, and speed. Exceptional fossil sites like the Burgess Shale and Chungjiang preserve these creatures in stunning detail. These Lagerstätten give us a clear window into the Cambrian world. By studying these fossils, paleontologists reconstruct the first complex ecosystems. The Cambrian all-stars defined what it means to be an animal. Their legacy still shapes life today. If any group dominated the Cambrian, it was the arthropods. Their secret? A tough exoskeleton, segmented bodies, and jointed limbs, a design both protective and versatile. Trilobites, the most famous arthropods, filled every marine niche: scavengers, predators, and filter feeders. Their crystal-lensed eyes were among the first sophisticated visual systems. But arthropod diversity went far beyond trilobites. Creatures like Marella and early crustacean ancestors explored new ways to move and feed. Arthropods were ecosystem engineers, churning up sediment and creating new habitats. Their molted exoskeletons littered the seafloor, enriching the fossil record. The arthropod body plan proved incredibly adaptable, leading to their evolutionary success. Their rise transformed the Cambrian ecosystem. They set the template for animal diversity that endures today. While arthropods ruled, another group quietly debuted, the chordates. These small, soft-bodied animals had a notochord, a flexible rod that would one day become the backbone. Pikaia, from the Burgess Shale, was a ribbon-like swimmer and one of our earliest ancestors. Millicunmingia, from China, may have been among the first vertebrates with a head and gill pouches. These creatures lacked jaws or armor, surviving by swimming away from predators. Though minor players then, they carried the seeds of our own lineage. The internal skeleton pioneered by chordates allowed for larger, more complex bodies. This innovation set the stage for fish, dinosaurs, mammals, and eventually us. The humble beginnings of Pikaia and Miloconmingia connect us to the Cambrian dawn. Our story starts here in the shadows of ancient seas. What triggered the Cambrian explosion? It wasn't one thing but a perfect evolutionary storm. Rising oxygen levels fueled bigger, more active animals. Melting glaciers flooded the oceans with minerals like calcium, enabling shells and skeletons. The evolution of predation created an arms race. Prey developed defenses, predators got sharper. This feedback loop accelerated evolution, driving rapid diversification. Environmental, chemical, and ecological changes all played a role. The Cambrian was a playground for evolutionary innovation. Life's potential, long simmering, finally ignited. The result, a riot of new forms and possibilities. The Cambrian explosion didn't just create new animals, it reshaped the planet. Burrowing animals churned the seafloor, releasing nutrients and creating new habitats. The evolution of hard parts meant fossils became abundant, giving us a rich record of life's history. Food webs grew complex with producers, consumers, and multiple levels of predators. Interactions like predation and competition became major evolutionary forces. The basic ecological structure of today's animal life was established. The phyla born in the Cambrian have endured for 500 million years. From insects to humans, we all trace our roots to this creative burst. We live in the long echo of that ancient explosion. The Cambrian explosion was a creative surge that changed Earth forever. In a geological instant, animal blueprints were set, filling the oceans with strange and wonderful life. Our own origins lie here, in the first chordates swimming among trilobites and anomalocaris. Every backbone, every animal is a legacy of this event. The study of Cambrian fossils is an act of self-discovery, connecting us to the deep past. We are all descendants of that first great flourishing. The story of the Cambrian is our story written in stone. It reminds us we are part of a living, ancient tapestry billions of years in the making.